solve for x exactly, then give an approximation. So we've got the x that we're looking for is in the denominator. We don't like things stuck in the denominator, so let's multiply it on both sides. So we multiply by the natural log of 2x minus 3 on both sides. So we get 4 equals 2 times natural log of 2x minus 3 on both sides. We can distribute the 2. 4 equals 2 times the natural log of 2x minus 3. The thing we want to figure out is it's like we're solving for natural log of 2x, and then later we'll crack the log. But for now, let's just figure out solving for natural log of 2x, and then we can crack the log. So we see 3 on the minus 3 here. We add 3 to both sides. We get 7 equals 2 times, oh, whoops, haha, made a mistake. Important thing to notice. It's 2 times natural log of 2x minus 3, so it's 2 times negative 3. It's not minus 3, it's minus 6, right? So I have to always be careful with distribution because it can catch anyone, including me, including your teachers. You always have to watch out for distribution. So add 6 to both sides, we get 10 equals 2 times natural log of 2x. We divide by 2 on both sides. We get 5 equals the natural log of 2x. We now raise both sides to the e. So e to the 5th, e to the natural log of 2x. Since these are the same base, natural log and e, they cancel out, and we've got e to the 5th equals 2x. So we've got that e to the 5th over 2 equals x. That's our exact answer, right? E to the 5th over 2. Now, e is this complicated irrational number. We can't really, turn it into, it's not exactly a decimal number, but sometimes we want to have a decimal approximation because that makes it easier for us to work with things. So e to the 5th over 2 is the exact answer. That's what it is precisely. But if we want an approximate answer, e to the 5th over 2 winds up being approximately 74.207. Great. Now, if we want to do a quick check, we can do a numerical approximation where we try plugging it in using a calculator. So we'd have 4 over the natural log of 2 times, replace our x, which we know is approximately 74.207 minus 3. You work that through with a calculator, and you wind up getting approximately 1.99999, and then it winds up changing after that. But that's really, really close, so we know that this checks out numerically. We've got that close to being exactly 2, so we see that numerically, because remember, there is some rounding error when we get an approximation. So with that little bit of rounding error, we're still extremely close, so we know that that's a good answer. If we wanted to, we could also work it out and show that it winds up being a precise answer as well, that e to the 5th over 2 is going to be equal to precisely what x has to be. We can check by plugging that in. 4 over the natural log of 2 times e to the 5th divided by 2 minus 3. So 2 times dividing by 2, they cancel out. So we've got 4 over the natural log of e to the 5th minus 3. E to the 5th minus 3, e to the 5th is going to wind up being, so we've got 4 over natural log of e to the 5th has to be 5, because what do we raise e to, since natural log is base e? What do we raise e to get e to the 5th? Of course, we raise it to a 5 exponent. 5 minus 3, we could also think about the fact that natural log is log base e, and we've got an exponent base e, so they cancel each other out. 4 over 5 minus 3, 4 over 5 minus 3 becomes 2, which equals 2. Hey, that checks out. So we can do it either numerically, or we can do it precisely and see that it worked in either case. All right, great. Now I've got a really good understanding of even probably the most complex kind of logarithmic and exponential equations that will be thrown at you at this point in math. So with this sort of knowledge, you can go forth, do all kinds of problems from the easy to the hard ones, and you'll be able to knock them out if you follow these things. And remember, be careful. Mistakes happen. You even saw one happen to me. So they happen to everybody. It's really useful to do these checks. By checking your work, you can make sure that you didn't make a mistake. And if you see something went wrong in the check, you can go through and carefully analyze your work and figure out where things went wrong. All right, we'll see you at Educator.com later. Bye.